Today let's look at the matrices section of the 2025 Exam 2 paper. Question 11. An early learning center contains 3 rooms: nursery, toddler and pre-kinder. The nursery toddler rooms have a capacity of 8 children, and the pre-kinder rooms have a capacity of 20 children. So this matrix basically tells you the capacity of each room. Matrix E shows the enrollment numbers from Monday to Friday. The first question is, state the order of the matrix E. So there's 1, 2, 3 rows by 5 columns. 1, 2, 3, 4, 5. And so you write that in the boxes 3 by 5. The following matrix multiplication has been completed to determine a new matrix W. So they've taken a row matrix consisting of ones and multiplied it into E. So if you had multiplied this matrix into a 1, 1, 1, the answer that you would have got is the first answer. Now this is a 1 by 3 matrix, so you know that finally you will get a 1 by 5 matrix, which means 1, 2, 3, 4, 5. And so the first answer will be 1 times 6, 1 times 6 plus 1 times 7 plus 1 times 18. So if you look at what it's doing, it's summing the columns. The second answer would be 1 times 8 plus 1 times 8 plus 1 times 18. Now, the number of answers you would get would be equal to the total number of nursery toddlers and pre-kinder students present on each of the weekdays. So that's Monday, Tuesday, Wednesday, Thursday, and Friday, from Monday to Friday. So this question is asking you as to what information does matrix W provide regarding enrollments at the early learning center. Matrix W provides the total because you're summing, the total daily enrollment of children across all 3 rooms for each day of the week, Monday to Friday. So the important thing you have to remember is you have to connect what the rows represent and the columns represent in each of the matrix. So you have to talk about each day of the week, and the answer is the total daily enrollment. So the mark is given for this and that. If any one of these pieces of information is missing, you tend to lose the mark. You should also remember that any matrix that looks like this is a summing matrix. So the word total should definitely occur in the answer. And if it is a 1 by 5 matrix that you get on multiplying, the 5 represents the Monday, Tuesday, Wednesday, Thursday, and Friday. And 1 is the total of nursery, toddlers, and pre-kinders. So that is the 1 and that is the 5. So because this is one answer, you talk about the total. Okay? It has been decided that the capacity of the nursery room be increased by 25%. So nursery is increased by 25%, which means that to increase anything by 25%, you multiply by 1.25, and the toddlers will be increased by 50%, which means multiply by 1.5, and the capacity of the pre-kinder room reduced by 10%. So if it's to be reduced by 10%, you multiply by 0.9. The new capacities can be then determined by the matrix product. The new capacity is equal to F times the C matrix. So here we can see that the C matrix is the initial capacity in each of the rooms. And if you have to multiply a diagonal matrix, very important, this question is very popular, by the C matrix, which will help you either increase or decrease as mentioned, you have to come up with a matrix that will give the new capacity in each of the classes. So what you're basically doing is you are multiplying this matrix C given. This is your NT and P. This is just for my own understanding that I write NT and P. You can also write that outside. And this is a 3 by 1 matrix by, and if you want a new capacity matrix, you are obviously again asking for NT and P, whose order is also 3 by 1. Now, in order to get a 3 by 1, this 1 comes from here, and if there should be a matrix F, at this moment we will delete that because we're just trying to see how this answer comes about. And in order to get this particular 3 in the solution matrix, it has to be a 3 over here. And in order to be able to multiply, this should be equal to 3 so that these two are equal. The number of columns of the first matrix should be equal to the number of the rows of the second. And that implies it should be a 3 by 3 matrix. Now, what you should remember is the capacity of the nursery room is to be increased by 1.25. Now, if this has got to be a 3 by 3, I usually place 3 by 3 here, and then I think, what is it that I want? Okay, so I want just 8 to be multiplied by 1.25 because it's only the nursery that's increased by 1.25, and it's in the first position. So if it has to multiply 1.25, it is the first position element. Okay, now if you look at these answers over here, this one is the first row, first column answer. This one is the second row, first column answer. And this one is the third row, first column answer. And this is, by logic, 8 times 1.25. Which means when I multiply the first row into the first column, that is the only calculation I want. So this first row into the first column should be 8 times 1.25 and nothing else. So 8 is sitting here in this, and its first position, so the first position should be 1.25, and if the other numbers do not multiply any other number, the other numbers should be 0. Now let's look at the second one. This one is the second row, first column answer, and we wanted the toddler room to be increased by 50%, which means 1.5. Now it's in the second position, and therefore this calculation I want is 8 times 1.5. Now if that's the case, because it's in the second position, the 8, okay, this is the toddler, I want the second position to multiply by 1.5, which means this row, the second position, should be 1.5, and that's the only calculation I want, and so the remaining will be 0. Now this third position answer is to be reduced by 10%, which means what I want, third row, first position answer, the only calculation I want is the number of pre-kinder students, which is 20, to be multiplied by 0.9. And this is the answer to the third row, first column. So the third row is this one, and the first column is this one. Now in the third row, when I multiply, I want 20 times 0.9, which means this position times this position should be equal to 20 times 0.9. So in the multiplication, I don't want anything to multiply 8, anything to multiply this 8, and only 0.9 to multiply 20, which means that 0.9 should occur in this position and everything else should be 0. So if you think logically, you should be actually able to, just by understanding how multiplication works, be able to get an answer. The next question, question 12, says from 1 year to the next, children can move between the rooms. The following transition matrix shows the expected proportion. So M shows the expected who will move between these categories. Now the number of children expected. Now something that I forgot to mention here is you do not, this is how you get the matrix F, but the answer, you can do this somewhere separately or in pencil, and you have to, the only thing you write is this answer, because that is your F. So you can do this logical calculation on the side somewhere in order to be able to decipher what F is going to be. The way you look at it is, if there are 3 values that have to be increased or decreased, it has to be pre-multiplied by a 3 by 3, because a diagonal matrix is always a square matrix. Okay, and so which implies that if you want 3 answers, it has to be a 3 by 3 matrix. If you have 2 answers that you need, it will be a 2 by 2 matrix. Okay, now moving on to question 12. So these 2 children are moving between these categories. The number of children expected to be in any one of the 4 categories from 1 year to the next can be calculated by this matrix relation. Now, Sn represents the expected children at the start of year n. Very important to have a look and read carefully as to whether it's a start or the end. The state matrix 2024 shown below, okay, gives the number of children at the start of 2024. Now they go backwards and ask you find 2023. This is an application of Ax is equal to B. So x is equal to A inverse B. So they have given you that a transition on 2023 is equal to 2024. Okay, so if 2024 is given, so it is a transition on 2023. So this is Ax, which is my unknown, okay, is equal to B. So that implies x is A inverse B. And so if you were to just substitute that from the given information, A inverse, so here M inverse B. So we have M from here. We put that into the calculator, M to the power -1, and this is my matrix S 2024. S 2024 should give you S 2023. So you put that into your calculator, and you should be able to get S 2023. Part B says, from the start of 2025, new children commence in the Early Learning Center at the start of each year. A matrix recurrence is given for determining the expected number of children in each of the 4 categories from year to year. Now, the minute you see something like this, now all this time you have been working with a transition equation, which is that, okay? But now you have got an extra plus B. Now this is what we call non-transition equations, where you really can't do a direct calculation. You have to do 1 year at a time for any calculations. So B is given to you. Now, usually they'll ask you what B represents, but here they say gives the number of new children enrolled in each room at the new children. So sometimes they'll say what's the total number of new children that have been enrolled at the learning center at the start of each year. So all you have to do is add 12 plus 5 plus 10, and that gives you 27 new students. Okay. Now, some students say 12 in the nursery, 5 toddlers, and 10 pre-kinder, but that is not the total. Okay, so you have to add them up. Given the state matrix as this new matrix, okay, now they also here introduce a new one called leave. Okay, so many students, children leave each year. Find the expected total number of children to be enrolled in the early learning center, rounded to the nearest whole number. Now S2024 has been given, and they're asking you S2026, which means 2 calculations are required. So looking at this, S2025 is a transition on S2024 plus B, and then S2026 is another transition on S2025 plus B. There is no direct calculation when you see something like this. Okay, so when worked out, you have to actually write all this out for S2025. Don't write it the way I have done. You have to put the values in, and it gives you this answer. Now you may say, do we have to round this up because they are children and then substitute in this place? No, you don't. You take directly the decimal places, copy paste it here, and for this particular equation you don't have to sub in the numerical values again. You can just write as I have written, and you will get the answer that you see here. Now at this point you can actually round, but it doesn't matter because they're asking you the total enrollment. So just add what all the values you see. But what you have to be careful with is this is nursery, this is toddler, this is pre-kinder, and this is leave. The mistake many students made was they just added everything. Okay, but the ones that leave are not enrolled, so you do not add that, and that gives you 50.30625 to the nearest whole number is 50. So expected number of children to be enrolled at the start of 2026 is 50. Question 13. The Early Learning Center offers 10-week activity program for 4 children. There are 27 children enrolled in the program. They participate in 3 different activities: cooking, gardening, and music. And matrix K gives the expected proportion who will change activities. Okay, proportion to change activities. I usually write what each matrix represents because it helps me think, okay, from one week to the next. What do the zeros in the leading diagonal of matrix K represent? Now there can be various explanations. One of them is 0% of children repeat an activity in consecutive weeks, and the zeros indicate that no children stay in the same activity from one week to the next. So either of these can be answers. Now the leading diagonal, for those who don't know, is from the top left to the bottom right. Okay. In week 1 of the program, all 27 children participate in cooking. Now, so that implies, and the question says, what percentage of children will participate in cooking in week 10? Now, if they haven't asked you how many children, and their question is a percentage, you can actually work it out the way I have shown you. Now, because the information given to you is week 1, okay, in week 1, all 27 participate. All 27 represent 100%. Okay, so because the question says percentage, I have put 100% as 1, and there are no children in the other activities. So this one represents 100% of children. And if that's week 1 and they want the number of students cooking, okay, in this position in week 10, you can say state in week 10 is k, because k is the transition matrix given here, to the power of, it's a non-transition because the columns do add up to 1 over here, but I repeat that. Because the number of students in the first week is given to you, we only have to calculate 9 transitions on the first week matrix. And that, when we put into the calculator, gives these values. And you have to write it exactly as you see it. And then you have to decide. The question asks you only those who will participate in cooking, and that will be this one, which has to be multiplied by 100, and it is 37 point to 1 decimal place, 37.4%. Okay, this converted to 1 decimal place is 37.4%. The next part of the question asks you, find the expected number of children who will participate in gardening in week 3 and then move across to music in week 4. So in S1, because here they've asked you the expected number of children, so you have to take 27 against cooking. In the previous one, they said percentages. So in those questions, you can actually represent 100% as 1. Okay. So in week 1, there are 27 children against cooking. In week 2, it's a transition on week 1. And we take the k value from the previous part of the question. And this is the answer we get. In week 2, again, we have a transition on the second state. And you should take it exactly as you see it, no rounding. And you get this answer. And in week 3, the question asks you, what is the expected number of children who will be participating in gardening? Okay, so we have to find how many will be participating in gardening and then moving to music in week 4. So this was the number of children who were participating in gardening in week 3. Now, in week 4, okay, the percentage of children who will be moving from gardening to music, okay, can you see? Gardening to music is 24%. Okay, so 24% will move. Now, if you had calculated so the percentage that will be moving from gardening to music is 24%. Now, so that implies that 24%, which is the second place on this particular row, will multiply the second place. So 24% of those in gardening will be moving to music. And so you calculate 24% of 7.776, and that gives you 1.86624 approximately 2 as requested. In the next question, the Early Learning Center runs 7 different activities, and these activities are, as you can see, cooking, drama, gardening, lunch, music, reading, and sport. And this is the order of activities. So the timetabled activities have been given to you as a matrix X, and this obviously it's according to the time from 9 a.m. to 3 p.m. And then they give you a matrix P is a permutation matrix because it consists of ones in every row and column, one set of 1, 1, used to determine the timetable order of activities from one day to the next. A column matrix containing the timetable order on one day is multiplied by P to determine the timetable for the next day. State the activities that will now always be held at the same time on each day of the program. So if you multiplied the matrix P into the matrix X, okay, you will find that this being in the 1, 2, 3, 4, 5, 6th position will multiply the 6th position. It's the diving board method of multiplication, and R will be the activity that comes out first. And in the second row, it is in the 7th position, and therefore that will multiply S, and S will come out next. In this particular row, it's in the 3rd position, in the 3rd row, 3rd column, and therefore the 3rd row element will come out next, which is G. And in this row, this is the 4th element, and therefore it will multiply the 4th in this position, and L will come out next. In this next row, it is the 5th position is where 1 is, and which implies that it will multiply M, and M will come out next. And in this row, 1 is in the 2nd position, and therefore it will multiply D, and D will come out next. And finally, in the last row, it's in the 1st position, and 1 will multiply C, and C will come out next. Now, if you look at the elements that are in the same position on multiplying, are G, L, and M. Okay? G sits in the first row first. G is 3 here, L is 4 here, and M is 5 here. And G is 3 here, L is 4 here, M is 5 here. And if you look at the others, they have changed positions. So state the activities that are always held at the same time on each day of the program. It is gardening, lunch, and music. Now, what you have to be careful in this particular question is that they have not told you whether you will be multiplying X times P or P times X. Now, that is the main thing. You could have swapped and done it this way too, but you should check, is that possible? This being X is a 7 by 1 matrix, okay, and this is a 7 by 7 matrix. So you know that if P is a 7 by 7 matrix and X is a 7 by 1, that is possible, and that will give you the another column of activities on multiplication of P and X, because these two are equal. But if it had been X times P, 7 by 1, and this P is 7 by 7, and these two are not equal, and therefore that would have not been possible. So, and that is why you multiply P times X in order to be able to determine which 3 activities will be held at the same time on each day of the program. I continued to work for day 3 also, and I still found that G, L, and M are in the same positions. Okay, so this was basically the permutation matrix into day 2, which gave me day 3. Determine the timetabled order on day 3. So that was how I got it, and that is the order in which it occurs. P4 is an identity matrix. Explain what this means for the timetabled order of the activities over the 40-day holiday program. Now, if P4 is an identity matrix, that implies that activities rotate on a 4-day cycle. Okay, 10 cycles completed, because if it's a 4-day, then there are 10 cycles in 40 days. Ongoing, repeating 4-day cycles. Now, an identity matrix is a matrix that leaves a column matrix unchanged when multiplied by it. It's essentially equals 1 in the in matrix maths. That implies that the daily permutation 4 times brings you back to the original starting order. Okay, and so the answer is, you can answer in easy ways, whichever day you want, but I think activities rotate on a 4-day cycle and 10 cycles completed, ongoing repeating 4-day cycles, any of these can be answers for this particular question. Thank you.